Okay, good morning, everyone. Essentially, I will talk about the things we were discussing in the previous talk and my experience with Bokeh trying to automate the release process. So that's the title of my talk. Well, let's go ahead. Essentially, I will try to make a simple demo here. I will try to build a dev build on a stage. Obviously, this maybe will not work. I will check at the end of the talk. My name is Damian. I'm from Argentina. I'm working for Continuum Analytics. I work from Argentina, and thank you, Continuum, to bring me here. I contribute to several open source projects, essentially Jupyter, Bokeh, and Nicola, and some others. And I also a biochemist, biostatistician, a kind of quant in my free time. I do a lot of things. The idea of this talk is essentially to tell people about some of the Bokeh needs in terms of building a successful devel or release package. Essentially show how we solve this problem in the Bokeh project itself, so people maybe can take some of these ideas or tips and use it in their own projects. So the first problem we have is that Bokeh is a little bit complex from the packaging perspective. Essentially, we have a Python side and a JavaScript side, and we have to take these two things together and ship it, or ship that thing to the user. And there is also bugs reports, and we know how to fix that thing. And essentially, we want to provide our users with an easy answer to their problem. And, or maybe we can show a very early feature, and we cannot ask the people to go to GitHub and set up all the devel environment. It's not so complicated, but it doesn't make too much sense. So we need to provide something that the users can essentially get or download a package, essentially, to get the latest features or the bug fix for the problem they report. So we need essentially to set up a machinery to build devel packages for those intermediate points between the official releases. So previously, we used a simple script to locally generate the packages using conda build to actually build the Linux-based packages for 3 Python versions, and then conda convert to get all the platform-specific packages, or X, Linux, and Windows. Then we have the packages, and we need to upload to our Anaconda now, or Beanstalk channel. And one problem we had in that time is that we didn't have the corresponding Bokeh.js and Bokeh CCS, which is important to get from the CDN for Bokeh itself. And neither the docs were specific for that devel version. So the first things we do is was to make the JS and CCS files version aware and build docs for each of those devel builds. And all these things were done manually. Obviously, that making a devel build usually took me a lot of hours, and that's very time-consuming and very annoying. So we need to make something to do all these things programmatically. And here is where automation goes. And we need an agent to make all these tasks instead of me. And essentially was Travis, and not Travis Oliphant. This is my chief. It was Travis CI. And Travis CI is a hidden build machinery, and it's not so hidden as you saw in the previous talk, and probably a lot of people is using Travis CI to build other things. But then we had a new problem. We have to make Travis CI make different things. All the tasks we do it previously, or we did it previously manually. So essentially, to do that, we have a Travis YAML file where you can make the Travis CI platform make something, and also you can call your own script from there to perform some other specific and more specialized tasks. So one of the first things we have to do is to make Travis CI build our own packages as we did it manually before. And that was relatively easy to do because we already had that for our testing machinery in place. And here is a short snippet of the code to make that. It's really easy to do on Conda build, or using Conda build. Then we need to make Travis CI convert our packages to all the available platforms. And it's easy to do it using Conda convert. And if you see the command there, you will see here the Travis build ID. And that is related with the previous command. We needed to label all our devel packages in some way. And one interested way, or one way to do is using a monotonically increasing sequence, so the people can get the latest devel packages easily, just doing Conda update bokeh from our own channel. And to do that, we use a Travis CI environment variable called Travis build ID, which essentially do that. We use another Travis CI environment variables. We will see that later. So after that, we need to make Travis CI to build and upload the docs. And that's essentially easy too, because our docs are Xfin bases. So it's just use a make file to do the docs. And the tricky thing is to upload those docs to our own server with the fab update dev below. As I said before, that is relatively easy if you know how to deal with secret keys inside Travis CI platform. Essentially, you have two ways to work with secret keys in the Travis CI platform. The first one involves working with encrypted files, and the second one with encrypted environment variables. If you work with encrypted file, you can put all the interested files, CCH keys or config files, whatever, inside a tar file, and you encrypt that using the Travis CI command line application. Then that application output a thing, which is essentially here, that you can put in your Travis YAML file, and then when the Travis CI platform run the build, it is able to decrypt that file and use all the credentials you want to use. So you here you will see some bokeh key to connect to our own server, and there are other things here to connect to other things and to complete the release. I will talk about that later. And the second part, or the second way, is using environment secret variables. Essentially, through the command, the Travis CI command line application, you can put there your password, and that is encrypted, and you get something like this that you can insert in your Travis YAML file, and then when the Travis CI build run, it is decrypted, and you can use it in your own script just with the name of the environment variable you previously encrypt before. So the other thing we need to do is to make Travis CI upload the Bokeh.js and Bokeh CCS into the CDN. In that case, we are using Rackspace. And this is easy to do if you know how to do it, but I didn't know. So I have to investigate and learn about that. Okay? And essentially, you can communicate with the Rackspace API with the REST communication or REST, through the REST API. And with API credentials, you can get the token and an ID. And essentially, with that, you can push your files, in our case, the Bokeh.js and Bokeh CCS files, using that token and that ID. And you had to be aware of the content type. In our case, we need to upload a JS file and a CCS file, so you have to put the right content type to make it right. Then we need to make Travis CI know when he has to run the build machinery, because we don't want to build packages for every commit because of all the problems we discussed previously. And essentially, you can signal that using or tagging your repository, and this tag is available in the Travis CI machinery through the Travis tag environment variable. So you can filter when you want to essentially run the build machinery. So at this point, we have a machinery in place to create dev builds automatically, all in the Travis CI platform, and give that to our users when we want. Yes? The third problem is try to complete the automation of the release process. Our release process has several steps. The first is update the versions of on the repo itself, generate a change log, tag the release version, build the packages for all the platform, build and upload the docs, and upload the JS and the CCS into the CDN. As you see, the three last point is covered by the dev build machinery. So if we automate the top three, we are done with the complete automation. So manually, it usually took us several hours to do a release, essentially maybe a complete working day. So we thought about, let's reuse the dev build machinery to automate all of the process. So programmatically, we changed the version numbers in our code base. We generated a chain log from our GitHub issues using a Python script, essentially, which is able to understand how we manage the issues and PRs in Bokeh itself. We have a common protocol to manage issues and PRs. But that you can do that, or you can do a previous human validation to see that everything is OK. Then we need to programmatically inject the chain log into our docs, make automatic commit of these changes, tag and trigger the build on the Travis CI platform. So how we detect if we want to, or how to signal that we want to make a dev build or a real release. And that is relatively easy using or signaling with the correct tag. Essentially, if you want to make a dev build or a release candidate, we include in our tag the dev string of the RCS string. Otherwise, it is a real release. Yes, and to filter this out, you can, in your YAML file, you can allow to the Travis CI platform to run in some specific branches. In that case, it will allow to run on master for our testing machinery. And then you have branches that have the semantic version and the dev string, the semantic version and the RCS string for dev build, and the semantic version for the real release. So we have constraints about what things we want to run. And in that way, we don't release something undesired. And you are done. Essentially, previously, we have 1 day for make a release, and today to make a release on Bokeh with complete documentation and upload to the CDN and upload to the our Beanstar channel. It's just making that call in your terminal. Well, let's see how it goes. Probably it's still running because it takes 20 minutes. Let's see here. Okay, still it's running. So well, that's all. I can show you later. Here is running. If you want or if you go to the run itself, you can see how the process goes. Essentially, we are building packages yet, but that's all. I hope that can help you a little bit with your release process. Thanks. Yeah. Yeah. Yeah, that's okay. In Bokeh, we sorry? The question was about how to deal with the commits from other developers and how that it's interpreted in our change log in some way. To don't have awful things. Essentially, we on top of this, we have a very tight way of managing our issues and PRs, and how that is a process, and it is documented in our BIP2. So essentially, we have previously to run the thing, we have a human validation. Using the same script, you can see that the chain log generated, if the chain log generated is compatible with the thing we want to publish, and make the change if it's not the case, it made the change. So then when we actually build, we get the correct change log. But there is a human validation there. We can't escape of that. We build packages for Windows, essentially using Conda Convert, but we don't run the thing in a Windows CI project. But essentially, you with Conda Convert, you can convert from Linux to other architectures without problems. So people in Windows can install our packages without any problems. And right now, we have something new called a no-arc architecture, which allows you to use a single package it's not in place in Bokeh itself, but it's something in the Conda world, which with the single packages you can install in any platform. Okay, thanks.